Good afternoon. Hello. My name is Andy McDonald, and I'm with Apogee Climate and Energy Transitions located here in Frankfort, Kentucky. I'm also with the Kentucky Solar Energy Society, a nonprofit organization that promotes solar energy in Kentucky. And I will be making a presentation today about a solar and battery-powered mobile walk-in cooler. And after the presentation, anyone who's interested in seeing it can step outside with me on the patio just outside is the unit I'll be talking about. And you can take a look at it, and we can talk some more about it out there if you wish. A couple years ago, Kentucky State University wanted to develop a portable walk-in cooler that they could take to events and have as a display and demonstration for farmers and others. And the initial design didn't work well. They used an air conditioner modified with a CoolBot, which I'll describe some more, and mounted it inside the trailer, and they put in some insulation, and they just had it so that it could be plugged into grid power. And it didn't maintain the temperature. It didn't drop the temperature to the cool temperatures that they wanted. And so I was doing some work with KSU at the time, about a year and a half ago, examining their opportunities for using solar energy on the campus, and became aware of this project. And so I started working with the land grant program to renovate the trailer, increase the insulation, and add solar panels and batteries so that it could operate off-grid. And so the end result was they were starting with, I believe it's a 16-foot trailer. We partitioned it to create a 10-foot by 6-foot cool storage room, and then a smaller back rear storage area where you could store tools and the batteries. And the goal was to be able to keep the temperature anywhere above 33 degrees Fahrenheit. So depending upon what vegetable or what products you're storing, there might be a range of temperatures. The cooling was provided by a conventional window air conditioner modulated by a CoolBot Pro. An air conditioner typically will only cool down to 61 degrees because we generally don't want to cool our houses any more than that. A CoolBot is a device that was developed maybe 2 decades ago, which overrides the thermostat in the air conditioner so that it keeps running. And then it operates off of the thermostat in the CoolBot device down to the temperature you want it, as low as 33 degrees potentially. And so you can see in the photo here, the CoolBot's on the lower right-hand corner of the picture. It's a small electronic device, so you can adjust the temperature setting that you want in the room using the CoolBot. And so the CoolBot attaches to the air conditioner and to the thermostat on the air conditioner and overrides the thermostat on the air conditioner. And so my wife and I have a farm on the north side of Frankfort. We put in a walk-in cooler using a window air conditioner and a CoolBot about 20 years ago, and it worked really well. The CoolBot's really a great device for helping you create a homemade do-it-yourself walk-in cooler that doesn't require the traditional equipment you might get if you bought a commercial walk-in cooler or refrigerator. And so the CoolBot technology was adapted for this purpose, but the other thing that's really important is to have adequate insulation and air sealing in the room that you're cooling. And so this image shows how there was a partition wall that was built to separate the rear part of the trailer, which is where the batteries would be stored. Let's see. I'm going to go back. I think I missed a slide I wanted to mention. Yeah, on this slide I mentioned also the insulation that we used. We used Green Guard extruded polystyrene foam board, which we bought at Lowe's. It's a common foam board insulation. We used 4 inches of foam board on the wall and the floor and 6 inches on the ceiling. And I did some heat load calculations during the design process to estimate what the heat loss would be through the walls and the ceiling to try to get an idea of how much insulation would be adequate for what we were trying to do. And my calculations suggested that this would be adequate. So that would be 4 inches of insulation, of the foam insulation in the walls and the floor, and 6 inches in the ceiling. And the idea was, yes?
I was going to say, on your floor for the cooling, would that not make it difficult to put containers or pull things in and out?
It didn't make it difficult. You'll see when we go out to look at it, and this is an image, gives you a bit of a close-up of the floor. It did raise it up above the normal step, so it makes it a little higher to step into the trailer. And we put, Lowe's sells these plastic panels that you can put over, like in a kitchen, you can put them over a wall so that they're easy to wipe down. We put that on the walls, and we put linoleum on the floor, and then we taped the edge with an aluminum tape so that it didn't trip and snag. But I don't think basically we just made the floor a little bit higher than it was before. You can evaluate for yourself whether that makes it more inconvenient. The headroom is shorter. It's 10 inches less high than it used to be, so you have to crouch down a little bit if you're, unless you're a little bit shorter than normal, to get in there. And so if you were to try to do this yourself, you might look for a trailer that has that's a little bit taller, so you have more headroom after you add the insulation. But for the purposes, you're just walking in and out. You're loading things in, getting out. You're not spending a lot of time inside there, I wouldn't expect. And so I don't think it would end up being an issue. So that was the functional part. Was we wanted it to stay cool and be a useful space, and we wanted to be able to power it when we were off grid. And so we put 1,200 watts or 1.2 kilowatts of solar panels on the roof of the trailer, which you can kind of see in this photograph here. And so that was 3 400-watt solar panels wired together. And then we used a type of battery that's called EcoFlow in the cooler. And EcoFlow is one of a variety of batteries that are available today. They're a sort of a plug-and-play, consumer-friendly type of battery that can be integrated with solar panels. The really nice thing that I like about the EcoFlow is that to connect the solar panels to the battery, you just use the standard wire that comes with the solar panel and plug it in. There's no electrical wiring, no screwdriver required. You don't need any type of electrical training at all to be able to plug it in and start operating the unit. The screen on the front of the battery, well, the battery system incorporates an inverter that converts, the battery stores current in, it's a direct current battery. It needs an inverter to convert that to AC power so that it can operate standard appliances like the air conditioner and the CoolBot. Commonly, more going back into the past, off-grid solar systems using batteries would require a separate inverter, a separate charge controller to moderate the charging of the battery and make sure it doesn't get overcharged, separate devices for surge protection and circuit protection. All of that gets integrated into the EcoFlow unit. and there's no exposed wiring or exposed parts that would be dangerous. You can also charge the battery with the alternator of the vehicle, so you can plug into the cigarette lighter of the vehicle and plug the other end into a port on the EcoFlow battery to charge it with your vehicle. You can plug it into grid power, so if you don't have solar panels or if it's been very cloudy, you can plug the battery into a grid source to charge it up. And the batteries, we put 3 batteries into the unit. There's one battery is like the control battery that has the interface that gives you information about the battery. It has the receptacles you can plug into. And then there's 2 supplemental batteries. You can expand the original EcoFlow by adding 1 or 2 additional batteries. And doing that's very easy. They give you a cable with a special plug, and you just plug them in together. It's very easy. So with the 3 batteries, we have 10.8 kilowatt hours of energy available, that's the total energy. These are lithium-ion batteries. They work better if you don't drain them all the way to 0 when you're using them. They work best if you only drain them to 20% of their total capacity. And so I accounted for that. So we have 8.6 kilowatt hours available. And that's assuming there's no solar gain. The EcoFlow also allows you to use the solar energy directly as it's available. And so when the unit's in operation, parked in the field, say you're harvesting your produce, this is parked in the field. If it's sunny at all, the sun's going to be charging the batteries. Once the batteries are charged, the electricity is available to operate the air conditioner CoolBot unit and maintain cooling. If you want to operate other appliances, if you want to operate a fan or a rechargeable tool or an electric lawnmower or a weed eater, anything like that, you can operate with these batteries as well. They have a plug on them, just like a standard plug you can plug into. And it can either operate directly from the sun, if it's sunny, or draw from the battery. So there's a lot of versatility built in to the system in that way. So this here gives you a close-up of what the face of the battery looks like. You have the 4 receptacles you can plug into. You have the button that turns the unit on. The screen in the center, you see there's a 97 in a blue circle. That's the percent state of charge of the batteries. The 14 on the left is the number of hours until it gets to a full charge under the current conditions. On the right, it shows you how much power is coming in from the solar array and how much power is being drawn by the appliances connected. And there's also an app you can put on your phone if you wanted to do that. So the goals of the project that we designed around were to allow at least 2 full days of cooler operation, assuming no solar gain. That's like assuming heavy cloudy weather during the hottest time of the year. And so because it's a cooler, we were designing for the summertime, assuming that's when you'd want to use a cooler most often. And you could, when you're doing an off-grid design, you need to think about how many days without sun do we need to plan for. And here in Kentucky, if it was your home, I would encourage you to plan around 5 consecutive cloudy days when you have no solar gain. That's if you're off-grid. But that requires more batteries, more investment in batteries. So we were, you have to weigh the cost of more batteries versus how often you're going to have to need all that battery capacity. And also in the summertime, you have fewer occurrences of extended days of cloudy weather with no sun. And you also have longer days when even if it's light sun, like a day like today, you're going to collect a little bit of solar energy on a day like today. And if you have 10 hours like of cloudy weather, you're going to get more energy than if you have 4 hours, which is what it is in the wintertime. So that's how we planned it. And as I said, the solar energy, when it's coming in, can run the cooler directly or any appliance you're using, and it can recharge the batteries. If it's cloudy, it'll draw from the batteries. Or if it's nighttime, you know, the cooler, if you're storing something there for days and days, you need it to run at night. And so you've got the batteries, and the batteries will drain overnight. So in the design phase, we estimated how much energy we needed each day to operate this for a full day. The estimate I came up with was 4.2 kilowatt hours. That would be the amount of energy required to keep the cooler at 38 degrees on a hot day. That took into account the outdoor temperature, the volume or the mass of produce we would put into the cooler. The largest factor, other than the outdoor air temperature, is the temperature of the produce you're putting into the cooler. So if it's like 90 degrees outside and you're loading it with like heavy tomatoes that are 90 degrees, the cooler is going to have to cool them down too. So something to keep in mind if you're operating a system like this is cool your produce down before you put it into the cooler in order to get better performance from the cooler. So like say it's zucchini or heads of lettuce. If you can dunk them in cold water before you put them in the cooler, get some of the heat off of them, then the cooling unit doesn't have to work so hard to drop the temperature, and the batteries won't get drained as much. I'll talk a little bit more about what we've learned, but before I get to that, on this particular unit, the solar panels and the battery equipment and the installation of them cost $7,600 approximately. So KSU contracted my company and to do the design and install all of this equipment. So that was their cost. The installation materials cost about $2,400. And that's all apart from the trailer itself. The cost of the trailer is not reflected here. KSU purchased the insulation, and their staff insulated the trailer. And I installed the batteries and the solar equipment. So this was installed in the summer, this work was done in the summer of 2024, and then it sat over the winter here on the campus. And then this past summer of 2025, there was folks who were farming at a farm about 10 miles from here. They were growing produce for the public school in Frankfurt, and they needed cooling, access to a cooler on the farm. And so we brought the trailer over there, and they used it for about 3 months this summer, from about June through August, I believe. And it was quite hot this summer, and it actually worked very well. The batteries never got drained below 20%. I wasn't monitoring the lowest that the batteries got to, but they never cut off. The batteries are programmed so that if they got to that 20% state of charge, they would turn off to protect the battery, and that didn't happen. So it ended up working very well. The people who were using it really, they just showed up every morning and used it, put produce in, took produce out, and it worked well. The biggest negative lesson we learned was that when we installed the insulation and the plastic paneling, we used an adhesive, something like liquid nails, which ended up having a very bad odor, like a chemical odor. And that odor has not gone away yet. And originally we specified a zero VOC, zero odor adhesive, but it didn't adhere to the plastic paneling and the insulation. And so at the last minute, we went to Lowe's and got some different stuff that worked as an adhesive, but it wasn't good from the odor that it created. So we need to continue airing out the cooler. So for those of you, for anyone who might be considering building something like this, more thought would need to be given to how to air seal the unit and how to protect the foam, what kind of covering to put on the foam. I've had further ideas about how I would do it if I did it again. Yes?
I was going to say, in one of the pictures, it appeared you had built like framing on the inside. You couldn't have drilled those panels into the wood framing?
That's a possibility. That framing was only for the rear partition, however. For the side walls, we just attached the foam. The trailer, has these metal ribs. They're like 2-inch by 2-inch ribs. That's like the frame of the trailer. And we put a foam in between the ribs, and then we put another 2 inches outside the ribs. We could have screwed into those ribs, and if I did it again, I probably would do that. The more challenging part is how to get the plastic panels or any other type of paneling to stick to the foam, particularly on the ceiling, because gravity is working against you. But I think just screwing up probably would be the best thing in the future. In terms of the EcoFlow battery, it's worked pretty well. It doesn't like, or its temperature range, its operational range is like from 30 degrees up to like 110 or 115 degrees. So I was concerned that being in the trailer in the summer, it might get overheated. And we considered putting in a fan. There are a couple small vent holes, but we did not put in a vent fan. And as it happened, apparently it never did get to excessively high temperatures inside the trailer, inside its storage compartment, because it never shut down due to high temperature. If you were to try to use it through the winter, like if you had some other reason you wanted to use the trailer for electricity in a wintertime location, you would just need to be mindful that if the temperature got well below freezing, the battery might stop working. Or the EcoFlow actually has an internal heater that boosts its temperature. So it would need to be pretty extremely low temperature for that to be an issue. But for using it as a cooler, that's not really a concern, because in the wintertime, it wouldn't matter. So that's my contact information there. If you ever wish to reach out, I'd be happy to share more information with you if you ever want to reach out to me. I have the plans. They're not really professionally formatted, but I have the information we used in the construction of the project. I'm speaking with KSU about putting together a nicer quality handout about the project that KSU can share with folks. But I'd be happy to talk with you. Any other questions before we go outside?
On the grid system, I think in rural areas where there are more remote and you don't have the ability to run electric out there, and I need to put the prices up there, but did the off-grid system, the solar panels, the battery, the pool bot, are we considering that all in the price that you quoted there?
The price did not include the air conditioner or the cool bot. The price included, for the solar PV and battery line, that's the rails and the solar panels and the screws to mount it on the roof, the wire to get it inside, and the EcoFlow battery. And for the installation, that included the plastic paneling, the insulation board, the adhesive that we use, some screws, things like that.
Were your extra batteries included in that?
Yeah, yeah. And EcoFlow is, commercially available. You can buy that off of different websites. It's really nice for a consumer because it's ready to use when you buy it. You can plug the solar panel right into it. If you want to use it in a more finished setup like a home, it does take some mounting, some attention to how to mount the panels. You need to be careful about that sort of thing. But it is very easy to use as a battery inverter charge controller unit all built into one.
Converter came with it as well?
It's part of the EcoFlow unit. Yeah. You can see it when we go out there. Well, why don't we go outside now and you can take a look at it.